the simulation report from our digital twin simulations, which is the core of why those simulations we have are so powerful. First of all, important to understand, this simulation you see here is done by using the exact same software in the digital environment as it is in the physical environment. Meaning the movements you see from the robot is the same movements you can expect at the same speeds you can expect from a physical environment. Additionally, what's triggering the different movements are there's actually an invisible sensor here, so the robot, if there's no boxes, it would stop moving. So we get the same type of I/O signals being triggered as in a real-life robot. Additionally, when we do it like this, we can get data which is far more accurate than other simulation types. As example, how many boxes per minute will this setup be able to reach given this palletizing pattern? As you can see, we were able to reach 17.97 boxes per minute when the requested number in this simulation was 14, saying yes, that's successful. We also get speed of, in this specific simulation, what's the maximum speed that was reached by the robot. This is important when doing risk assessment. Someone would say this is a bit too high number for a collaborative simulation for collaborative robot, but you are allowed to set the safety settings yourself. So if you did a simulation running on a maximum 750 millimeters per second, this number would never go above 750, which would make cases per minute slower. So doing it like this, you get the ability to test whether a certain safety limit will match different production requirements. Additionally, you see the average of pallets per minute and the different metrics of the product, the pallet height, and the palletizing pattern. Also, if I'm using the imperial metrics, I can simply check off this box and you will see it's converting. But moving down here, you can also see what hardware has been used in this simulation. So we used the new Easy Palletizer, PTP 1000. For the frame, the robot is a UR10E. We used the Gripper PIAB CPT 500 foam version, Evolix 700 stroke, and no gripper bracket, and now mounting bracket for the robot. We can read out what are the key distances that's been used. So if you want to replicate this as exact you can in an installation, you can read it here. And also what is the software versions we've been using to run it. So we're using the Universal Robot Polyscope version 5.12 with the Pali Eurocup version 2.12.1 and some certain software settings. So then you know if this is what you're running on the robot, this is also how it would perform. Further, there's a very important functionality. This simulation, as you can see, it's on a web page, meaning it can be shared if you have anyone you would like to show it to. If you want to show it to a customer or any other person within your organization, I simply see, okay, so how many days or weeks or month do I want this simulation to be available for a third party or a third person? So if I check off 3 months and I tick this box, I'm making a link that's available on my clipboard, which I can send to anyone I would like. If you want to see how that works, I open a new incognito window here, so I'm not logged in. I copy the link I copied in the link that I just generated, and you will see here is the same. Here's the same palletizing simulation as I just showed. What's different is that you see there are some buttons that's not here. There are some functionalities removed. So there are slight differences that's not available. You can't rename the simulation and so on because you're not the admin of this specific simulation. Okay, that's what I want to show for the simulation report.